In this lesson, we're going to dive a little bit deeper into domain and range. First, we're going to look at definitions of domain and range. Second, we're going to look at some examples in context. And then third, we're going to look at an algebraic example. The domain of a relation can be defined as the set of all possible inputs for a function. The range of a relation is the set of all possible outputs for a function. A simple way to remember this is that domain comes first in alphabetical order, and so does the word input, and so does x. Range comes second in alphabetical order, and so does output, and so does y. You also might be familiar with the word range from data analysis, where we take the maximum minus the minimum. It's very similar here, but in this case, we're talking about the range of a relation and not the range of a data set. A couple of more words that we need to officially define are discrete and continuous. A discrete function is a function with distinct and separate values. This means that the values of the functions are not connected with each other. It's used for things that can be counted, like number of puppies or number of shoes that you own, things that can be counted. When you see a graph like this, where there are separate dots that are not connected, that is an example of a discrete function. One of the reasons why it's important to be able to identify discrete variables is sometimes you'll be presented with a word problem and you'll be tempted to connect those dots, but then when you look at the variables, it doesn't make sense to have in-between variables. For example, if this was number of puppies, we wouldn't want to connect the dots because that would indicate that you could have half a puppy, and half a puppy is just plain sad. For continuous functions, on the other hand, you do connect all of the dots. So every point on this line is another point. So even though they're not graphed and we only have one point that's actually marked, everywhere on this blue line is another point. In fact, we couldn't possibly graph all of the points. Like we couldn't put dot, 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 because there's infinitely many points in this line. For continuous functions, the function can be any value within this certain interval here. It's used for things typically that are measured, like height or weight or time or age. Money is a continuous function typically, but not necessarily things that can be counted. You don't count your age so much. You could be 2 years old and 3 months, 2 years old and 3 months and 1 day, 2 years old and 3 months and 1 minute. So there's a lot of in-between values there. So it makes sense to do a continuous function for that particular variable. What does that have to do with domain and range? Well, domain and range is a little bit different for discrete and for continuous functions. For a discrete function, to find the domain or range, you simply list the numbers in each set because they're counted. They're concrete, like discrete, concrete numbers. So for example, this is a discrete function here. It's just simply listed out each element in the set. Suppose that the relation t is defined as follows. T equals 8n, 8p, and 6m. So 8 is paired with n, 8 is paired with p, and 6 is paired with m. Okay, notice it's not a function, but we can still talk about the domain. It's not a function because 8 is paired with n and p. Uh-oh, he's cheating on n with p. Okay, so the domain is just 8 and 6. We don't list any repeats, so we wouldn't put 8 and 8 again, just 8 once and then 6. And it's usually lowest number to highest, but it doesn't really matter. And then the range is n, p, and m. You're just simply listing out the outputs, the second numbers in each set of ordered pairs. For a continuous function, it's a little bit different. The domain and range will be identified by intervals. Over here we have a continuous function. It's not just separate dots. It's everything between these two dots is going to be in the domain and the range. So the domain is the leftmost point to the rightmost point. So domain is x's, right? And x's go from left to right. So if you're doing domain, that's your x's, that's your inputs. You're going from left to right. So what's the furthest left that this graph goes? It's 0. And we're going to identify what's on the x-axis here. And what's the rightmost point? If I go the furthest to the right, I land at this point, and I want to go down to the x-axis here, and that's 30. So the domain is all x's, all real numbers between 0 and 30. We couldn't possibly list all of the points in between those two, because remember, there's infinitely many points on this line. So the only way we can describe the domain here is to say it's between 0 and 30, including 0 and 30, because we have closed dots on those 2 points. And the range, just like I said, the range for a data set is you subtract the maximum minus the minimum. The range here is very similar. It's the minimum value, the minimum y value, the lowest one you have, to the highest one you have. So the minimum is 150. And the max, again, we're looking at the y value, so I don't go down again. I go over to the y-axis here. The lowest value I have is 150, and the highest value I have is 240. So the range goes from 150 to 240, including 150 and 240, again, because these are two closed dots. We're going to look at one more continuous graph before we look at examples in context and some algebraic examples. It says to find the domain of the graph. I actually found the domain and the range because I'm a little bit extra. And then it says write your answers using inequalities. So this is what it means when it says write your answers using inequalities. I also wrote it out in words because sometimes assessments ask for it written out like this in words. And so I wanted to show you what that would look like. Okay, so first, what's the difference between this graph and the one we did before? Do you see? If you said it has an arrow on the end, you are right. It does start at 0. Some of you might have said that, but this is the key point here that's different, is that it doesn't have an end point over here. It's still continuous, so it's going to be a range of numbers, but it's not going to have a maximum x value, and it's not going to have a maximum y value because it goes on forever in this direction. But it does start at 0 for the x, and its 0 is less than whatever x is. Or you could write it as x is greater than or equal to 0. You can flip that around if you want. In words, that means all real numbers greater than 0. Everything that's greater than 0. For range, it's still the same thing. The minimum value is 0, and then it goes on forever. And it says all real numbers greater than 0. If by chance you get a graph where there are arrows on both ends and it's straight like this, then the domain is all reals. It doesn't have a lowest point. And the range is all reals. It also doesn't have a lowest point. Moving on past definitions, we're now going to look at an example in context. The Sugar Sweet Company delivers sugar to its customers. Let C be the total cost to transport the sugar in dollars. Let S be the amount of sugar transported in tons. Okay, S is sugar, C is cost. Got it. The company can transport up to 20 tons of sugar. That's a lot of sugar. Suppose that C equals 140 times S plus 2,500 gives C as a function of S. Okay, so what that means is that for any value of sugar, you can figure out how much it's going to cost by taking 140 times the amount of sugar and adding 2,500 onto it. There wasn't actually a question here, but the question is find the domain and range, because that's what we're talking about. Real big over here. The domain of a function is the set of all possible inputs. So for this one, the input is the amount of sugar, S. So that's the first thing you have to think of is, what's my input? Well, my input is whatever it says it's a function of. So in this case, it would be S, sugar. So the values in the domain correspond to the amount of sugar transported. How much sugar can we transport? Well, we can transport none. So the domain, the lowest amount we could do is 0. And what's the highest amount of sugar that we can transport? It says up to 20. So the domain is all real numbers between 0 and 20 tons. It makes sense to be all real numbers because we could do like a half a ton or 0.1 of a ton or 0.01 of a ton. So all real numbers make sense. If it says integers, that's where it's a discrete function where in between values don't make sense. It only needs to be whole numbers, things that you can count. Okay? Makes sense for it to be negative numbers. That's why I started with 0. You wouldn't transport a negative. It doesn't say starts with 0, but it doesn't make sense to transport negative amounts of sugar. The range is the function of a function is the set of all possible outputs. Okay? So to figure out the range, we can see that 0 tons would give us the smallest cost here, and 20 tons would give us the maximum, most expensive cost. So if I put 0 in for S and I do 140 times 0 plus 2,500, I get the minimum cost would be 2,500. And then 20 tons is my maximum amount of sugar. So if I put 20 in here and I do 140 times 20 plus 2,500, I get $5,300. That's the most amount of money that it would cost them. And again, it's all real numbers because our domain, our inputs could have been like fractional decimal parts of tons. And so our cost is also going to be fractional decimal parts of money. So it'll be all real numbers. If it can't be fractions, it would be integers. All right, the last thing I want to talk about very quickly is an algebraic example. This is a little bit advanced, but I wanted to put this in here because I think it's important for you guys to understand the full range. That's not a pun. The full scope of what domain and range can be. So find the domain and range of the function f of x equals the square root of x plus 4. So again, domain is the possible values which we can input into this function. If you get nothing else from this video, domain is the inputs. In this case, the radicand is limited to only positive values. You can't take the square root of a negative number. So x has to be greater than or equal to -4. Okay, if I put -5 in here, I'm going to get a negative. Do you see that? Because -5 plus 4 would be -1. If I put -4 in here, I get 0, and I can take the square root of 0. -3 I put in here, plus 4 would be 1. I can take the square root of that too. So the domain is x is greater than or equal to -4. The range is the possible values which are outputs of this function. In this case, the value of the radical will only be 0 or positive, so you can only have things that come out of a square root be 0 or anything bigger than that. So y also has to be greater than or equal to 0. So my range is anything bigger than 0. So hopefully this little deeper dive into domain and range has been helpful for you, and hopefully you have a better understanding of those concepts.